All right, where were we? We were talking about the simplified flexure formula and how we can use the section modulus to figure out our bending stress. And our flexure formula was just moment divided by section modulus, that shape factor for whatever our beam is. I've stuck those into our good old Miller diagram, our triangle thing here, because you'll notice we have three terms in this equation. So if we want to rearrange those, we could do that. We could use good old algebra, or we could use the good old triangle. So for example, what we've been doing is just figuring out how much stress in a beam. So that'll be stress equals moment over section modulus. That's the book points out, yeah, that's called analysis. I don't care. That's what we're doing. We're finding bending stress. But what if you want to design a beam? What if sometimes in a book it'll say design a beam that does such and such. What they mean is pick out the size. If you want to pick out a size for a beam and you know what the load is on top of it, well, look here. If you know what the load is, you can figure out the bending stress using these diagrams and our AISC formulas. So you'll figure out the bending moment. You know how much stress will occur. And then you figure out, all right, how big a section modulus do I need? So you get some, by rearranging these terms in your triangle, you get some section modulus number, and then all you have to do is go look at your steel table or your timber wood table and look up who has a section modulus that is at least that big, and you will wind up with a beam that's big enough. All right, let's work our way through a couple more beams. First of all, here is a cantilevered beam, so it's supported at one end and not supported at the other end. It's got a 2,000-pound load out on one end. It's made out of wide flange. It's a W8 by 18, so it's a smaller wide flange. And this steel beam has an allowable stress of 22,000 psi. If you think back to when we talked about factor of safety, you might recall that this is a very standard allowable stress number from AISC. So sometimes AISC, to be more precise, will say 21,600, and sometimes, just rounding off, AISC will say 22,000. But this is a very common allowable stress with a factor of safety of 1 2/3. So you'll see this number show up a lot. And what we want to know is, what is the bending stress in this particular beam, and is that safe? Is it less than the allowable stress, or is it more than the allowable stress? So first we'll convert foot-pounds to inch-pounds. All of this is given in feet and foot-pounds, so let's go convert that. We already have here our maximum bending moment, which says the maximum bending moment is negative 18,000 foot-pounds. Let me just interject here for a second. This bending moment happens to be on the negative side of the graph, but that doesn't matter. We don't need to worry about what direction it's bending. Is it up or down? Is it positive or negative? All we need to worry about is how big is the number. So you'll see diagrams where some bending moment is above the zero line and some is below the zero line. All we care about is how big is it. All right, where were we? We're going to convert 18,000 foot-pounds to inch-pounds. So there are 12 inches to the foot. 18,000 times 12 is 216,000. And we are abbreviating that with the letter K, just so we don't have to keep writing zeros all the time. But if you are a fan of writing the zeros, as I sometimes am, because I feel insecure, here they are. 18,000 times 12 is 216,000. All right, so we have a wide flange that's W8, that's its size, its nominal size, by 18 pounds per foot. Let's look up its section modulus. And I have given you another handout for today. This one is the page out of the AISC manual that includes the 8-inch wide flanges. And let me zoom in on that section that we're interested in so we could read it. They're right. I used Photoshop to move this up and zoom in. So our size of beam is 8 by 18 pounds per foot. Here is our column that talks about section modulus around the x-axis. There's the x-axis. So the section modulus for an 8 by 18 is 15.2 inches to the third. Alrighty. So now we can find the bending stress. We converted our bending moment to inch pounds, so it's 216,000 inch pounds. We just looked up section modulus. It's 15.2 inches to the third. Here's our good old Flexure formula. Our bending stress is bending moment divided by section modulus. And there are the numbers. 216,000 divided by 15.2. Let's do our unit analysis, canceling out the inches, and we're left with pounds per square inch, and you'll get some stress number there in PSI. And that stress number turned out to be approximately 14,210. It was actually, I got 14,210.526 PSI. When we're doing engineering work like this, once we're ready to take our final step in the process, at that final step, it's okay to round off. So we want to keep our decimal points until we get to the very end so that we don't introduce rounding error. But once we get to the end, where we are now, we can just round off and say, all right, 14,210 is close enough. And we were given that the allowable stress is 22,000. Question is this safe? Well, our actual stress is 14,210. That is, in fact, less than what we're allowed, 22,000 psi. So therefore, yes, it is safe. And these three dots you might remember from structures class. I think we introduced them then. That is the mathematical symbol for therefore. Some engineers use those. Some engineers never use those. I'm in the former camp. I like them. All right. Now what? Let's look at a different beam. Here is one that's a little bit fancier. See, you got, it's a simply supported beam. It's got two supports. It's got a concentrated load that's not centered, and it's got an overhang with a distributed load out there on the overhanging end. How about that? And it's a wood beam, happens to be Douglas fir or larch, that category of strength. And this particular wood has an allowable bending stress of 1,300 psi. And like we did with the previous beam, we're going to find out, is this one safe? So all we know is what it's made of. Here are the loads on it and its sizes. If we know the allowable stress, are we okay? Are we safe? So here are what the shear and moment diagrams are going to look like on this beam. And if you want to, you can look up in your AISC shear and moment diagram handout. Somewhere in there is a shape that where the loads look like this, and you could see. Anyhow, we're going to go on and find out how big is the bending stress, and is that okay? Now, in this particular beam, you will notice that there are actually two maxima. Maxima is the plural of maximum, so you could have one maximum or two maxima. In other words, there are two peaks in the bending moment diagram. One happens to be above the line, positive. One happens to be below the line, negative. And we don't care who's positive or negative. We just care which one has the bigger number. And it turns out, when we look at those numbers, that, yeah, that one above the line is the bigger number. So we're going to ignore the other one and just focus on how big is the stress right here. So right now, before we go on, we know that the biggest bending stress in this wood beam is going to be right under that 2,000-pound load, whatever size it is. So let's convert that 4,280 foot-pounds into inch-pounds. 4,280 times 12 gives us 51,360 inch-pounds. All right. Now, we know that it's a 4x12 timber. It's a wood beam. Let's look up the section modulus. And again, as is our way, I have given you a handout. This is the same handout we got last time. I'm just giving it to you again so it's convenient. This is out of the back of our book. And our 4x12 timber is in the top half of the page, but let's zoom in on it so we can actually read the numbers. Here's our size, 4x12. Here's our column for section modulus. So section modulus for a 4x12 is 73.83 inches to the third. Let's find the bending stress. And by now you're kind of an old hand at doing this. You know that your simplified flexure formula just says moment divided by section modulus. That'll give you the stress. So let's plug in those numbers. Moment divided by section modulus. Let's do our unit analysis and we'll discover, oh surprise, we're left with pounds per square inch, PSI, which is the units for stress. Alrighty. And we come up with about 696 PSI as our bending stress. You'll actually come up with a number with some decimals in it. I think I got 695.652. Hopefully you did too. But I rounded it to 696 since we're at the final step of our analysis here. So our actual stress is approximately 696. Our allowable stress is 1,300 PSI. Is that acceptable? Is it safe? Well, before I even write it, you probably are already thinking, yep, 696 is in fact less than 1,300. The actual bending stress is less than the allowable bending stress. Therefore, yes, it is safe.